Year 12 and 13. This is the second part of question 1 in the 2016 integration paper. There are two questions. There's a merit question, which is a straightforward area under the curve, and then there's a nice, quite easy differential equation question for excellence. I say it's quite easy because it's really obvious what you've got to do, and as long as you've done plenty of practice at separating the variables and substituting, I don't think you'll find it too bad. So make sure that you've gone through it before I try. Sorry about the background noise, it's my kids cooking in the kitchen. Okay, so we're asked to find integration to find the area enclosed between the curve, the x-axis, and these values here. Right, so it's a very textbook problem of area under the curve. I've got the limits of 1.2 and 0, and this is my curve, e to the 2x minus e to the negative 3x dx. So I anti-differentiate and I get 1/2 e to the 2x plus 1/3 e to the negative 3x, evaluated at 1.2 and 0. Now I'm going to squeeze that onto the slide, so that gives me 1/2 e to the 2.4 plus 1/3 e to the negative 3.6. Take away 1/2 e to the 0 plus 1/3 e to the 0. But, of course, that's 1 and that's 1. So when we chuck that into our calculator, we get our answer, which I'm going to squeeze on the bottom, which is 4.69. So there you go. So that's a merit question. To get the integration, you had to do this step here. I guess you just had to get the integration right, and then the rest of it was the merit part. Okay, on to the differential equation. Okay, we've got a geeky maths joke. Mr. Newton has got a container of oil and he puts it in the garage. And it's on a nail, so it starts to leak. This is how the rate of decrease happens. The change in volume, dV by dt, is equal to negative kVt. V is volume of oil and T is the number of hours since it went into the garage. So as soon as you see that, you know that we've really only got one technique at level 3 for differential equations, and that is separating the variables. So we're going to do that to get an expression with V and T. Then we're going to have some constants that we have to figure out. The first thing that we're going to use is that at T equals 0, the volume of oil was 3,000 ml. So that's the first one. And then when T is 20, the volume is 2,400. And we have to find out what the volume is when T is 96. And we have to use calculus to do that. So I'll do that on the next slide. Alright, so let's start off with what we're given. So dV by dt is equal to negative kVt. We're going to separate the variables, treat this thing as a fraction, and we get 1 over v dv is equal to negative kt dt. And I'm going to integrate both sides. So on this side we have the natural log of v, and on this side we have, well, let's have a look. My variable's t, so that's going to go up to be t squared, so it's going to be negative k t squared, and that needs to be divided by 2. I'm going to put the constant of integration plus c over here on this side. I've talked about that a bit in the earlier video, that we don't need to have a plus c here and a plus c here, and if we do that, it's just going to make things harder, because it's just an arbitrary number. So we can have this as c1 and this is c2. We can put them together as c2 minus c1, and then we can just call that c. So that's really what we're doing, but we don't think about it like that when we've done a bit of practice. Let's probably make things far worse. Let me just get rid of that. So there's no constant of integration there, and there's just a plus c here. Here it comes back. Okay, but look, we have got two constants here that we've got to figure out. We've got this one and we've got this one. So that's why we've got to have two bits of information. The first one that we're going to use is that when t is 0, we know that our v is equal to 3000. So in here, we're going to have the log of 3000 is equal to negative k on 2 times 0 plus c. So that means that c is just the natural log of 3000. So that's my first one done. Now you might be thinking I've been a bit slack with not putting my absolute value signs in here. The reason I haven't done that in this case is that we know that it's a volume of oil, so it can't be a negative number, so I don't have to worry about that. It's totally fine if you put the absolute value signs in, it just doesn't make much difference. So now I'm going to figure out the next constant, and I'll do that on a new slide. So where we've got to is this. Natural log of v is equal to negative k on 2 t squared plus the natural log ln of 3000. Oh, sorry, there we are. Next we're going to use, when t is 20, v is 2400. So the log of 2400 is equal to negative k on 2, sorry about the singing, it's not me, times 400 plus the natural log of 3000. And we're going to solve that to get k. So let's see what we've got. I'll do it slowly. You can forward if you've already got this. So log of 2400 is equal to negative 200k plus the log of 3000. So what does that give me? Well, pulling this over to the other side, we get k is equal to the log of 3000 minus the log of 2400 divided by 200. Now we could simplify that top line, that log, a bit more. That's the log of 3000 over 2400. But most of you, I suspect, are going to pop that straight into your calculator there, and you'll get out this. K is equal to 0.00112. I'm rounding that just how they've rounded that in the schedule. Don't round too hard. Please don't round it to 0.001. You're going to get a bit of loss of accuracy as we go further. Right, so we're going to have that as our K now, and remember we've got this as our C. So we've got a complete determined equation that links V and T now. So on the next slide we'll put that together. Right, so we've got to this. The natural log of V is equal to negative 0.00112 t squared over 2 plus the log of 3000. Right, so we want to know what happens after 96 hours. So the natural log of V is going to equal negative 0.00112 times 96 squared over 2 plus the natural log of 3000. Now that gives me ln of V works out to be 2.8454. Don't stop yet, that is not the volume. Now we need to do e to the power of both sides. So V is e to the power of 2.8454, and that works out to be 17.2 millilitres. Okay, so you can see that after 96 hours, most of the oil has dripped onto the floor of the garage. Now, just remember, I'm thinking if you're watching this excellence question, you've probably got this pretty firmly, but how do I go from here to here again? Well, this is my graph of e to the x, right? And its inverse is this function here, which is the log of x. Right, so they are mirror images of each other. That's terribly badly drawn, but basically if we want to undo a natural log, we put e to the power of both sides. It's just if I had log to base 2 of x is equal to 4, if I want to undo that, I do 2 to the power of both sides. Okay, but we're working with e. Okay, so that's it for that one. So pretty straightforward for an excellence question. fingers crossed it'll be a bit like that this year as well. And let me know if you've got any comments or if I've mucked anything up. Thanks.